Assalamu alaikum, welcome back to my YouTube channel. In this video we will discussing about shear design of beam, a stirrup design. So we have given a simply supported beam with a 24 feet span. Superimposed dead load is 1.0 kilo kip per feet and live load is 1.2 kip per feet. Compressive strength of concrete is given as 4 ksi and yield strength of steel is 60 ksi for grade 60 steel. So we have required to design the beam for shear. So we will follow the following steps. Number one step is the H minimum. We have formula L by 16 into 0.4 plus Fy divided by 1 leg. So per grade 60 it is equal to 1. So we have L is equal to 24 divided by 16. So we will calculate H minimum is 18 inch. So we will multiply with 12 is because there is a unit consistency. So we will get answer in inches. Now I draw cross section of the beam. We have got 18 inch, so it increased by 3 inches and breadth is 15 inches. Now let's say the beam is 15 cross 21 inches. So we have cross section now 15 cross 21 inches. So next step is the loads, calculation of the loads. So for this we will calculate the self load of the beam. And that formula is cross section divided by 144 multiplied 0.15. So I am writing the formula. So we have got the cross section 15 cross 21 divided by 144 multiplied 0.15. So we will got the self weight of the beam. We know that the foot is equal to 12 inches. So divided by 144, 12 square is equal to 144. So we got the self weight is equal to 0.33 kg per feet. Now we are going to calculate the total dead load. So we have given the superimposed load as 1 and self weight is equal to 0.33. So adding these two loads we got 1.33 kg per feet. So we have got the total dead load. Now the ultimate load W is equal to 1.2 dead load plus 1.6 of live load. So this formula is factor of safety. So 1.2 dead load plus 1.6 live load, right? So putting this value in the equation we got ultimate load 1.2 into 1.33 plus 1.6 into live load is equal to 1.2 as given in the conditions. So you got the ultimate load by calculating these values. So it come 3.52 kip. So the third step is the shear demand. For this purpose you will draw the shear diagram. So the shear diagram is drawn here, you can see. Now I take one triangle from the shear diagram, and here the ultimate shear will be produced at distance from the support at 1.54 feet. So 42.1 is the shear and ultimate shear will be produced. So we will calculate the ultimate shear. For this purpose you can use here at the similar triangle ratio, that is 42.1 divided by 12 and VU ultimate shear divided by 12 minus 1.54. So we will get the ultimate shear or VU is 36.69 kg per inches. So this is the ultimate shear which will be produced in this specific beam. Now we will check the shear capacity of the beam, that either beam is capable of carrying the load or not. So that is called shear capacity. So shear capacity is equal to pi VC, and it is per the ultimate shear calculation. So is equal to pi VC is equal to 2 pi under root FC prime B cross D. So pi is equal to 0.75, which is shear constant. FC is equal to 4000 multiply 15 multiply 18.5, which is the effective depth. So divide this equation by 1000 as well, and we will get the shear capacity as 26.62. So this is the called the shear capacity, which is less than the shear demand. Now we will use excessive shear formula. So as the shear capacity is less than the shear demand, so excessive shear will be produced in this specific beam. For this specific beam, we will design stirrups to resist the excessive shear. Now we will find the spacing for the stirrups, that what distance we will use or provide the stirrups to resist the excessive shear. So the spacing formula is here, pi a Fi d divided by Vu minus pi Vc. So putting these values in the equation, we will get 0.22. Well, use number 3 bar in the stirrups. Here area is equal to 0.11 square inches. So the stirrup are in the two side, upper and lower region. So its area is equal to 0.22 square inches. Now putting these values, we will get 17.6 inches spacing. Let's say it is approximately equal to 15 inches. So now we will check these spacing that it is right or not. So there are three checks here. First one is the S is equal to check spacing for the right or not. So it is done for the checking the spacing, whether the spacing or the distance between two stirrup is right or not. So one check is A is equal to Fy divided by 0.75 Fc prime B is less than or equal to AFy divided by 50 into B. This is called one number check. Second one is the S is equal to D effective depth divided by 2, and the third one is equal to S maximum is equal to 24 inch. It means that never provide stirrups greater than 24 inches between their spacing. So S maximum is equal to 24. Now we will use the three checks. The least one will govern us to provide the stirrups in the specific beam. Least one governs. It means that the distance between two stirrups must be minimum to provide the stirrups in this specific beam. So from the above equation, 18.5 inches is less than 17.6 inches, which is wrong. Now use second check. S is equal to D divided by 2. So D is 18.5 divided by 2, which is equal to 9.25 inches. Now the third one is S is equal to 24 inches. Now you can see in the three checks that the least one governs. So the least one is 9.25, which is right, which is our design spacing. So we will use number 3 bar at the rate 9 inches center to center distance between the two stirrups. So this was all about the shear design of the beam.